Okay, this rule is really built off of our exponent rule, where if you have a base and a power divided by the same base with potentially a different power. So this is all based. Okay, so the quotient rule for logarithms says that if we're dividing two values, we can rewrite it as two separate logarithms that are subtracting. And this is built in the exponent law that says if I have a base and a power divided by that same base but a different power, I mean, I guess they could be the same, but that's comparable to subtracting the exponents. And we'll see this as we move forward, but subtraction is not commutative. And what that means is we cannot rearrange the order here. So it's very important that the numerator value goes first, so the denominator value goes second. And we'll kind of see that as we move forward. As far as a proof goes, we start off with, we have log A, I'll say given here. We start off with, we're given log base A of m over n. And just using exponents, again, kind of what we know about exponents, if you remember, this is equal to log base A m n to the negative 1. And that's just using those reciprocal laws of exponents. So if I have 1 over a to the n, that's equal to a to the negative n. It's built in that same exact idea. So this would be n to the negative 1. Really, from there, apply your product rule. So this is equal to log base a of m plus log base a of n to the negative 1. And I'll write this product rule. I don't want to run into myself. But that's your product rule here, right? Then apply your power rule. So you can move this exponent of negative 1 out in front. So this is log base a of m plus a negative log base a of n. And really, we can just clean that up. I don't need plus a negative. It's much cleaner to just write log base a of m minus log base a of n. And that's all we really need. There's not any kind of fancy rearranging or anything like that. If you know your product and your power rules, you can get to the quotient rule without any trouble. Okay? That's all that we have in this one.